Bum 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 bum.
Tomatoes?
Hello, welcome to video 4, an Unreal concept for persistent or savable objects. This one was kind of hard to name, mainly because it's kind of like a save game system, but it's meant more for saving objects that may be in the scene and things like that. So let me show you the basics of it and explain it. Traditionally, if we're playing our game like we are here, I have these little coins I can pick up, and my score goes up. Now I have 3 different maps. If you notice here, I'll collect all the coins on the blue map, go into the green door, and I have some coins on the green. If I go back into the blue, well, all my coins are reset. Even though my score is still saved, because I'm using the game instance to save between maps, these items themselves don't know that they've been picked up. I have nothing keeping track of it. So, if I was to grab my Saveable Object Manager here, let's go ahead and hook up our Saveable Object Manager. I need to go in here and I need to tell him to delete himself and hit play. Everything is going to look the same. Let me go ahead and hook him back up to not delete because I was testing earlier. And we'll hit play and we'll see a difference. Let's go ahead and pick up all of our blue items. Now our blue is clear. We'll go into our green. We'll go back to our blue. And we'll find all the items are still gone. We're using a save game, basically a savable object manager, to determine what's savable inside your map, if it's been interacted with or not, and then doing something appropriately. It's just as simple as that. So let's go ahead and look at this and what we might use it for. Well, actually, what we might use it for is pretty simple. You just saw what we might use it for. Let's say you have a persistent world. Let's say, I know I keep saying but as a really simple example, you have a world, you have houses, inside the houses are items. Those items exist at design time because your designer has put in these items. However, each item has an element of it that can be interacted with. If you pick up a coin, for example, that coin should no longer be there. Basically, it's you have a level that your player plays through, and actually, here's a really good example. You have your Super Mario games, and they have coins in them. Now, the coins are persistent. Every time you play through, the coins come back. But the newer ones have like the star coins. There's 3 star coins per level. Now, you could easily keep track of that in an array and say if coin 1, 2, or 3 was picked up. But let's say you wanted your Mario level to be kind of like a survival mode, where coins, when they're picked up, only are picked up once. If your player comes back into the game, they're no longer allowed to pick them up. They are basically objects that persist once, and then once your players interacted with them, they're done. They no longer come back. If you assign them as a savable object, basically, in this system here, it will keep track of itself, and your save manager will keep track of that item and then either allow it to be there or not allow it to be there whenever the map's reloaded. That's the goal of this. So let's go ahead and look through the code. And there's not too much code here. There's some old code here, but some of this code gets pretty funky when we start looking at stuff like this. So I'm going to do my best to go through it. Like normal, all this code is available on the public GitHub repo, and as much of this code as possible has been commented for ease of use. Now, we do have a bunch of things in here inside of our browser, but a lot of these things are just for decoration's sake. Things like our different maps, things like our different colors for the doors and the coins. Our Saveable Object Manager is actually something that is completely independent, as you may have noticed. If I don't have the manager in my scene, the game runs, and the game has a score that it can keep. And of course, we go back and forth, and it doesn't keep things persistent. But I get no errors. If I drop my object manager in there, my object manager can activate itself. And as you can see, it knows that I've picked these up previously. It's doing that using a save game object, but you'll notice it can use either method. So it's intended to basically be one object that's kind of self-sustained, and it will take care of itself. You just drop it where you want things to be persistent, and boom, it takes care of it. So, lots of words out of the way. Let's go ahead and look at everything. When this starts up, basically this is my debugging here to delete games. So I'm going to go and hook this up for now and run it so we can start from scratch. And we'll go back to here. Right now I'm using a unique slot name. If you wanted this to be persistent based on the map itself, the smart thing to do would be to basically have a different save game per map. So this map has this save game, this map has this save game, and it's going to go ahead and give you a lot better performance because you're only going to check one save game per map rather than for the entire game. I'm also going to show you an issue you run into using this method of one save slot because I had to work around not having individual save slots per map. Basically, we handle our save game object loading right here. And this is our simple little code. Basically, does our save game slot exist? Keep in mind for this example, I'm using one slot, and I'll show you why. And I'll show you the issue that happens from it. But do we have a save game? If we do, load up our save game. If we don't, create a new save game. It's all standard code here. If we have a save game itself, then we're going to go and want to load up the object array for all of our savable objects. We're going to get our current level name out of there. This is where the issue comes in that I was talking about. And then we're going to go ahead and set this level's savable objects as its own array. Keep track that we load it from a save game, and then store the index for later use. This, and things like this that we run into later are all because we're using one save game, one slot, for every single possible map. Now, I purposely did this incorrectly to show you the issues you'll run into. This isn't much of a problem if you have maybe one map or two maps. You don't have really a ton of things. You're not going to run into too much of a problem. Your problem is going to come into if you have 100, 1,000 items, multiple maps, different things like that. You're going to bloat your save game into multiple megabytes. It's going to be large because you have one save game saving everything, but you're also going to slow things down because you have to do different types of index searching because we're going through arrays. We have an array that stores everything. And you're basically going to say, hey, this small map with one item has to be treated the same way as if it's a save game which has 1,000 items. I'll show you how to fix this issue at the end, but we're going to continue on with this to show you that this is a problem by using one save game, and it's smarter to think outside the box from time to time and break things apart if you can. But all this does is basically, hey, if we have a save game, load up our objects. If not, create a new save game. Go back to our graph, and now at this point we have a little debug node I put in we're going to ignore, and we're going to say, hey, did we load a save game? If we loaded a save game, what we want to do is grab all of our savable objects on the map. We're using interfaces to determine if something is savable or not. So if I look at this little pickup and we look at its class setting, hey, it's flagged as savable. Because it's flagged as savable, our save game manager knows it should do something with it. So you only flag the things you care about saving. We're going to cache out all the savable objects in the map, and then we're going to go ahead and load the savable objects into the array. Basically, this is saying, hey, we have some objects we have saved previously. We need to update our scene with the correct state of those objects. So we're going to go ahead and want to grab all the objects in our current scene, and we're going to compare them to our saved game. And that's what this does right here. So this basically loads them all into an array, and we're going to basically continue repeating ourselves over and over. This right here is a way of getting around the infinite loop issue that you'll run into if you have too many objects. Basically, we end up looping through hundreds or thousands of objects, and Unreal Engine, in its nicety, is it under project or editor? I guess we'll find out right now. Infinite, nope, it's going to be under editor. This is not something most people run into, but okay, maybe it was under project and I just spelled it wrong. Let's do this again. We'll just do loop this time. There we go. Okay, it's called iteration. So this is what's known as the maximum loop iteration count, or for people who end up making mistakes, it's the infinite loop detection. Basically, if you accidentally do something like tell a loop to call itself, it's basically going to get stuck. This is a maximum amount of iterations or runs of something in a row before it basically kills itself automatically to prevent your computer from locking up. So it's something nice Epic has given us. However, when you're doing something that deals with a large amount of data, a common example of this is if you're making like a Minecraft clone and you have a couple thousand objects and you need to iterate through different positions and mutations, you're going to end up running into an issue where it won't finish the loop. It's going to give you an error. Well, by creating this little bit of code, basically what we do is we are loading up a set number of objects. Once we get to that number, we basically wait a frame and then we continue on loading up the next set of objects. So this is basically a way to offload work over multiple frames rather than all at one frame. So if you've ever ran into an issue where you have some things that you want to offload, you look into something like this where basically you call yourself, delay for a frame, and then continue back with what you were doing. And then you just do this over and over. Okay, that's if we have something. If we don't have something, we're going to get all of our items and we're going to go ahead and tell all of our items to do something. This is a generic interface event called interacted with. The interacted event is intended to be generic because you don't want to assume something should happen. For example, my coins, once I pick them up, their interacted event is basically to destroy themselves. However, what if the item that was savable is a light? And it is the state of the light, if it's, for example, turned on or turned off. Let's say your player has a house where the lights can be interacted with, and you wanted the player to be able to shut off all their lights, leave and come back and have all those lights turned on again. Or turned off again, sorry. You want them in a different state than the default. You would have the interacted event basically toggle the light of the state. The light of the state. The state of the light. I can show you that here shortly. But the point of keeping this generic is basically you have the ability for items to handle what happens if they've been interacted with. And all we're doing is saving that state, if it was interacted with or not. Let's look at the loading objects part, which is going to be this giant thing right here. This is the one I was talking about that can cause issues. This is loading our savable objects into an array. This is where we have our loop protection, and this is where we are determining the state of things. We basically determine in our main loop, we're going to loop through all the objects in our scene. And this is going to be based on all of our savable objects, everything in our scene. So at the start of this map, for example, we have 1, 2, 3, 4, 5, 7 coins. We have saved those at the start into a, let me close this and this, into our cached all savable objects. So we have 7 items in here. And we're going to get the current index value. Now the current index value is stored every loop because we're determining if we need to break or not. But basically get the savable values from the object. So we're saying, hey object, what savable values do you have? Reset our current loop counter. Loop through all of the savable objects in the map. Increment our loop counter as we go along. Go ahead and adjust our array based on if that object has been interacted with or not. And if we did interact with it, go ahead and toggle that. We have a match, and then we're going to repeat. So this basically is going to go through our loop, find matches, do something with that match, and then repeat. And it's going to repeat over and over through all of our objects. However, each time it's going to go ahead and determine whether or not we are too far along in our infinite loop detector. Basically right here, our loop count. If we are, we basically run that little bit of code I showed you earlier, and we tell it to pause, delay a frame, and then it's going to come back. Once we get to the end, we're basically going to make sure all of our items are saved through, clear out all of the saved ones, reset our cache to be equal to this new one, and then we're done. So long code short, basically go through all of our items in our scene and determine if we have a saved value for them. Have we done something with this in the past and saved its current value? If we have, go ahead and adjust its current value. Either interacted with on or off. Basically, did we get this coin or did we not get this coin? Did we flip this switch? Did we not flip the switch? Check and see how many times or how many objects we've looped through right now. If it's too many, we're going to go ahead and basically break out and wait a frame, a delay of 0, and call ourselves again, and then repeat where we left off. And we're going to keep doing all of that infinitely until we run out of objects in our scene. Processed all of our objects, basically. Once we've processed them all, we basically say, okay, now we have an updated status of all of our objects. We're going to go ahead and keep track of that for when the player messes around with stuff. We have an array of objects in our scene and everything has been touched. When someone touches something, we have our object. So for example, this is our pickup. And this is basically whether or not someone did something. So this is our overlap event. Someone picked up our coin. On coin pickup, we tell our character they picked up the coin. Then we're going to go ahead and update the Savable Objects array based on the current status of this coin. In this case, we destroy it when we're done. And we're going to tell it we've interacted with it. So this is basically saying, and I should probably take this code and move it over here. Like this, there we go. Basically saying, hey, did the player do something with us? If so, tell the player they did something. In this case, this is picking up a coin, so we get the score. And then the coin itself that we just picked up is saying, hey, array of saved items. We're going to go ahead and we're going to update the status of me inside of your array. And we're going to say, hey, we've interacted with it. So that way, the next time we load up this save game, it's been interacted with. So we'll know we want to turn ourselves on or off if it's a light, or we want to delete ourselves in this case. Because down here, our event interacted with is destroy actor. If this was a light, it would be if interacted with, turn on or turn off, whatever you want your default not to be. Or, you know, it could be a chest that opens to show it's empty. It could be whatever you want. This is our generic interface, which is specific to each individual savable object. And this is just simply where we're rotating the coin for just because it looks cool. That's all that is. That's why when we're playing our game, the coins rotate. So that is inside of our pickup. Now, our last function here is basically saving all the things, which I called it save all the things because we are technically saving all the things. We're getting our current level name. We're checking to see if we have a good save object or not. Basically, did we load this up with an existing object? Because if we loaded this up, we need to replace the existing object. If we didn't load this up, we need to create a new object. So if we need to write over old one, we're basically going to say, hey, savable game, save this level's objects to this index using this array. If not, we're just simply going to add it as a new array. And then we save out our game to slot. And this is a debug, which, again, I'm not using right now. That, for the most part, is going to be all the code inside of our Saveable Object Manager. We have a debug, which basically I tell it to print out stuff. It's an ugly mess only used for debugging. And then we have the break loop and get current object, which is basically just getting, it's a macro to get things shorter. There's a lot of messy code in here, I'm not going to lie. This is a project that went out of control. This is an example of something where it's basically in the middle life of development. And I'm going to leave it like this on purpose because I want to show you something that's functional yet not very efficient. By not efficient, I mean we have one save game object, which I called slot 1. That slot 1 controls different arrays. Each array contains the save values for each map. The more intelligent way of doing it would have been inside of our create or load save game right here. Having our slot name be the level name, because you know you can get the current level name. And if you just simply plug this into here, then our save game is going to be equal to the level we're in. Then you wouldn't need to have one master array which contained sub-arrays for each level. You would just simply have one array in your save game, which is for the level you've loaded up, because that save game is unique to that level. So that's something to keep in mind. You'd basically replace things like this with the level name, and then you'd basically be able to back out one loop. Because right now I have, if we look at our save game, because that would probably be important here. Here we go, save game. Our save game is an array of savable object arrays, which is of type struct savable object. Then if we pull up the struct savable object, we'll find this is an ID, an object, and an interacted with. And if we pull up our savable objects, we'll find this is a level name and a savable objects. So basically, if we were to, this would be the order. We have this save game, which has one object in it, which consists of multiple objects, which are level name and savable objects. And savable objects consist of multiple objects, which are what the actual interaction with was. The proper way would be to have basically this right here, our savable objects array, inside of our save game directly, and our save game is unique per map. So as you notice, that removes a whole level of abstraction, whole level of needing to keep track of the level name and comparing. We just simply have an array full of crap we want to do stuff with. It would make things super simple. But that's what I leave up to someone else to do as a learning experience. For now, this example is just intended to show a way of keeping track of stuff, doing things with that stuff, either in a saved or unsaved state, and then keeping it persistent among games plays. Because as you notice, when we hit play here, oops, yeah, we have our Saveable Manager. So I could just grab this one coin, leave, come back, and that one coin is gone. It's as simple as that. Now, if we go into our exits, this is one thing I definitely did not cover. We have our move to map right here when they touch the teleporter. If we are basically having a manager, that's where the save all the things comes from. Remember when I said we're saving everything? This is called by the exit, so that nothing is saved until you exit. So that's something to keep in mind. And since saving is technically a heavy process, you probably don't want to do it every time the player picks up things. You do it at checkpoints, you do it coming in or outside of a room, you do it things like that. But that's important to note, because you're manipulating. Now, this is what I meant by it could be heavy. If you notice, we've only got a couple things here. I've tried out an example of about 4,000 objects, and it takes 20 to 30 seconds to save and load out the entire map because of the amount of objects we have in our scene. Because we're basically inefficiently comparing items and going through and checking things out. There are more efficient ways of doing this, which I would highly recommend looking into. But for a simple setup, just at a higher level, all we are doing, just to wrap this up, because I'm going to wrap this up as our concept for the persistent variables and saving. At a high level, we are grabbing all of the items in our scene that are flagged as savable. We are determining if we have saved these items before, if we've loaded them up. And if we've loaded them up, we're telling each item what its current state is. We're saying, hey, you were interacted with, turn yourself on, or hey, you were interacted with, go ahead and delete yourself. Or we're saying, hey, you weren't interacted with, so nothing happens. When we leave the map, we are then grabbing all of the items inside of our scene, because we've technically have an array that's saved, that we're keeping track of everything, and we're writing that array out to disk. So that way the next time we come in, we load that array from disk, We tell all of our items if they're good or not, if they're saved or not, if their light's on or not, whatever we've done to it. And it's going to basically be an infinite repeating loop. Pretty simple in concept. It's not hard to implement. As you saw, there's a bunch of code, but since this is in blueprints, a lot of it is just for looks. If you notice, there's not too many nodes here. A lot of this is just safety checks and things like that. There's not a whole lot of code. It's pretty simple. Hopefully someone gets some use out of this, or at least the basic idea of using interfaces to determine if something should be saved and then doing something with it based on the status. So from an overview, I'm going to play through it one last time. When we hit play, it's going to grab all the objects in our scene that are savable, load up our save game object, go through all of our objects and say, hey, you were interacted with or not. So in this case, you'll notice one object is missing right here because I did interact with it. And then it's going to do nothing. It's done. When I grab this item is going to tell the array, hey, I've been interacted with, so go ahead and update yourself as me being interacted with. When I leave, it's going to go, okay, let's take that array of things, so all of our savable objects, and save it back out to disk. Next time I load up that map, it's going to go through and it's going to load up off the disk. It's going to know that it's going to say, hey, you were interacted with, nothing happened to you, nothing happened to you, and it's going to go along the list and tell everybody if they were interacted with or not. And it's just going to repeat indefinitely, you know, if we go in and out of maps. Really simple, really slightly inelegant because we're using a lot of array looping, with which if you go through this code, you'll notice it's kind of inelegant and inefficient. But it's not really that big of a deal if you don't have too many things. Again, this is a concept. This is, you know what? I've got a game and I want to save some stuff out and I want it to be persistent. But I don't want to hard code all of my stuff. Because the nice thing about this is because it's saved again based on individuality, I could easily go here, add 2 more coins like this, play my map. You'll notice these 2 are gone, but my new coins are here. I could grab this coin and this coin. We'll save out to the pink door, go back to the blue door. Those 2 are gone, and then those other ones are gone because we were able to save it out. Because these are savable objects and they each have all their unique information, it makes it nice and super simple to keep track of stuff. So that is going to wrap up our video, which I can't remember the name of. What did I call this one? What did I call this one? Hold on a second. There we go. That's going to wrap up our persistent or savable objects concept video. Again, all the code is available on the link below. And hopefully you get some information or at least some use out of this basic, simple concept.